What makes Saturn one of the most fascinating planets in our solar system? Is it the stunning rings that stretch far beyond the planet, or the countless moons that orbit it, each with its own unique story? From mysteries hidden in its atmosphere to the incredible discoveries made by spacecraft, Saturn is a treasure trove of wonders waiting to be explored. Join us as we dive into 10 fascinating facts about Saturn and uncover the secrets of this celestial marvel. Saturn's majestic rings. Saturn's rings are one of the most iconic features in the solar system, captivating astronomers and stargazers alike. Spanning up to 175,000 miles wide, these rings are composed primarily of ice, rock, and dust. Despite their vast size, they are incredibly thin, averaging just 30 feet in thickness. This extraordinary combination of scale and delicacy makes Saturn's rings a true masterpiece of nature. The rings are divided into several sections, with the most prominent ones named A, B, and C. Each section contains countless individual particles ranging from tiny grains to massive chunks of ice. These particles reflect sunlight brilliantly, creating the shimmering effect we see through telescopes. This striking beauty has earned Saturn the nickname, the Jewel of the Solar System. Scientists believe the rings formed relatively recently in cosmic terms, possibly 100 million years ago. They may be the remnants of a shattered moon or comet that was torn apart by Saturn's immense gravity. The ongoing interaction between the planet's moons and its rings creates stunning patterns, including waves and gaps, adding to their dynamic appearance. The Cassini spacecraft provided unprecedented insights into the rings during its mission. By diving through the gaps and analyzing their composition, Cassini revealed intricate details about their structure and origin. The findings not only expanded our understanding of Saturn, but also offered clues about the formation of other planetary ring systems. The rings may not last forever. Over time, they are slowly disintegrating as particles rain down onto Saturn's surface. This fleeting nature adds a poignant layer to their beauty, reminding us of the ever-changing universe we inhabit. The Hexagonal Storm. At Saturn's North Pole lies a bizarre and mesmerizing phenomenon, a massive hexagon-shaped storm. This geometric wonder was first observed by the Voyager spacecraft in the 1980s and has since been studied extensively by missions like Cassini. Spanning about 20,000 miles across, this storm is large enough to engulf Earth twice over. The hexagon's perfectly symmetrical shape is a result of Saturn's turbulent atmosphere. Scientists believe it forms due to a combination of jet streams and rotational forces unique to the planet. The storm rotates at an astonishing speed, with winds reaching up to 200 miles per hour, creating a spectacle of swirling clouds. Inside the hexagon, a giant hurricane-like storm rages at its center. This storm has a massive eye, nearly 50 times larger than a typical hurricane's eye on Earth. The striking contrast between the central vortex and the surrounding hexagonal structure adds to its otherworldly appearance. One of the most intriguing aspects of the hexagon is its changing colors. During Saturn's long seasons, which last about 7 Earth years each, the storm shifts hues, from a golden yellow to a pale blue. This change is likely due to the interaction between sunlight and atmospheric particles, providing valuable insights into the chemical composition of Saturn's atmosphere. The hexagonal storm remains one of the most mysterious and captivating features of Saturn. Understanding its formation and dynamics could unlock new knowledge about atmospheric phenomena, both on Saturn and other planets, including Earth. Titan, Saturn's largest moon. Titan, Saturn's largest moon, is a world unto itself. Larger than the planet Mercury, Titan has a dense atmosphere and a surface unlike anything else in the solar system. Its thick orange haze, composed mainly of nitrogen and methane, conceals a landscape of rivers, lakes, and seas made of liquid hydrocarbons. This alien world has fascinated scientists since its discovery. Titan's surface temperature is a frigid -290 degrees Fahrenheit, yet its geology bears a striking resemblance to Earth's. Rivers carved by methane rain flow into lakes and seas, creating a hydrological cycle similar to the water cycle on Earth. The Cassini-Huygens mission provided groundbreaking data about Titan. In 2005, the Huygens probe descended through Titan's atmosphere, becoming the first spacecraft to land on a world beyond Earth's moon. It captured images of icy plains, pebble-like structures, and evidence of underground reservoirs of water and ammonia. Titan's potential for life has sparked intense interest. Beneath its icy crust lies a subsurface ocean of liquid water, a key ingredient for life as we know it. The combination of organic molecules in its atmosphere and water below the surface makes Titan a prime candidate for future astrobiological missions. Exploring Titan further could not only reveal the secrets of this moon but also provide clues about the origins of life in the universe. It remains one of Saturn's greatest wonders, a reminder of the diversity and complexity of our solar system. The fastest winds in the solar system. Saturn is home to some of the fastest winds in the solar system, reaching speeds of over 1,100 miles per hour at the equator. These powerful winds are driven by the planet's rapid rotation, which completes a full spin in just 10.7 hours, the shortest day of any planet in the solar system. The winds create striking patterns in Saturn's upper atmosphere, including bands of alternating colors. These bands are composed of ammonia and methane clouds, with the lighter bands rising higher and the darker bands sinking lower. The interplay of these layers forms the planet's iconic striped appearance. Storms frequently erupt in Saturn's atmosphere, further showcasing the planet's volatile weather. One of the most famous is the Great White Spot, a massive storm that appears roughly every 30 Earth years. These storms can grow large enough to encircle the entire planet, leaving visible scars on its surface. The winds also play a crucial role in distributing heat across Saturn. Despite being nearly 900 million miles from the Sun, the planet radiates more heat than it receives. Scientists believe this heat comes from its interior, where helium rain generates energy that fuels the extreme winds and storms. Studying Saturn's winds provides valuable insights into the dynamics of planetary atmospheres. It helps scientists understand weather patterns on gas giants and their smaller cousins, the exoplanets orbiting distant stars. Saturn's winds remain a fascinating example of the raw power of nature. Saturn's gravity and low density. Saturn is a planet of extremes, and its gravity is no exception. Despite being the second largest planet in the solar system, Saturn's gravity is only slightly stronger than Earth's due to its low density. Saturn is so light that it could float in water, assuming you could find an ocean large enough to hold it. The planet's density is less than 1/10 that of Earth, primarily because it is composed mostly of hydrogen and helium, the lightest elements in the universe. This unique property gives Saturn its characteristic shape, a slightly flattened sphere due to the centrifugal force generated by its rapid rotation. Gravity plays a crucial role in shaping Saturn's moons and rings. The planet's immense gravitational pull has captured dozens of moons and influenced their orbits over billions of years. Saturn's rings also owe their dynamic structure to gravity, with moonlets within the rings creating gaps and waves that add to their striking appearance. Scientists have studied how Saturn's gravity interacts with its moons to understand tidal forces. For example, these forces create tidal heating in moons like Enceladus, causing geological activity such as geysers. This phenomenon demonstrates how gravity can shape the geological and atmospheric features of celestial bodies. The study of Saturn's gravity provides valuable insights into planetary formation and evolution. It also helps us understand how gas giants develop their unique characteristics, adding another layer of intrigue to this magnificent planet. Enceladus, the ocean world. Enceladus, one of Saturn's smaller moons, is a tiny world with a big secret. Beneath its icy surface lies a global ocean of liquid water, making it one of the most promising places to search for life beyond Earth. This discovery has transformed Enceladus into a focal point of astrobiological research. The moon's surface is covered in a thick layer of ice, which reflects nearly all sunlight, giving it a dazzling white appearance. At its south pole, geysers shoot plumes of water vapor and icy particles hundreds of miles into space. These plumes are evidence of the subsurface ocean and have been a treasure trove for scientists studying the moon's potential for life. The Cassini spacecraft made groundbreaking discoveries about these plumes, detecting organic molecules, salts, and hydrogen. These ingredients suggest that hydrothermal vents at the ocean floor could provide the necessary conditions for microbial life, similar to those found in Earth's deep oceans. Enceladus's geysers also contribute material to Saturn's E-ring, one of its faint outer rings. This connection between the moon and the planet highlights the dynamic interplay of celestial bodies within the Saturnian system. Exploring Enceladus further is a top priority for future missions. By studying its ocean and geysers in greater detail, scientists hope to uncover whether life exists in this distant, icy world. Enceladus is a reminder that even the smallest moons can hold the greatest mysteries. Saturn's magnetic field. Saturn's magnetic field is one of the most powerful in the solar system, second only to Jupiter's. Generated by the movement of metallic hydrogen within the planet's core, this magnetic field creates a protective bubble around Saturn known as a magnetosphere. The magnetosphere extends far into space, trapping charged particles and shielding the planet and its moons from harmful solar wind. This protective barrier also plays a role in creating Saturn's stunning auroras, which light up the polar regions in dazzling displays of ultraviolet light. Saturn's magnetic field is unique in its near-perfect alignment with the planet's rotational axis. This unusual feature has puzzled scientists, as it defies current theories of how magnetic fields are generated. The study of Saturn's magnetism could provide new insights into the internal dynamics of gas giants. The interaction between the magnetic field and Saturn's rings creates fascinating phenomena. For example, charged particles from the rings can influence the structure of the magnetosphere, while the magnetic field, in turn, affects the behavior of the rings. This dynamic relationship offers a glimpse into the complex interplay of forces shaping the Saturnian system. Understanding Saturn's magnetic field is not only key to unraveling the mysteries of the planet itself, but also to comprehend the broader mechanisms governing planetary magnetism in the universe. The Seasons of Saturn. Saturn's tilt of 26.7 degrees gives the planet distinct seasons, similar to those on Earth. However, because Saturn takes nearly 29.5 Earth years to complete one orbit around the Sun, each season lasts more than 7 Earth years, creating long and dramatic transitions. During its summer and winter solstices, the planet's poles are bathed in continuous sunlight or shrouded in darkness, creating stark contrasts. These prolonged periods of light and shadow affect the behavior of Saturn's atmosphere, with storms and cloud formations changing in response to seasonal shifts. The rings also reflect these seasonal changes, appearing brighter or dimmer depending on the angle of sunlight. During equinoxes, when the sun shines edge onto the rings, they cast thin shadows on the planet's surface, creating breathtaking sights captured by spacecraft like Cassini. Seasonal variations extend to Saturn's moons, particularly Titan. Methane lakes on Titan's surface change in size as the seasons progress, offering a glimpse into the moon's unique weather cycle. These observations provide valuable data about how Saturn's environment evolves over time. Studying Saturn's seasons helps scientists understand the effects of axial tilt and orbital dynamics on planetary systems. It also highlights the intricate connections between the planet, its atmosphere, and its moons, painting a vivid picture of a world in constant motion. Saturn's core and internal heat. Deep within Saturn lies a mysterious core that has long intrigued scientists. Unlike the solid cores of rocky planets like Earth, Saturn's core is likely a mixture of rock, metal, and ice surrounded by a dense layer of metallic hydrogen. This unique composition is the result of the planet's immense pressure and low temperature, creating conditions unlike anything we experience on Earth. The core is estimated to be about 10 to 20 times the mass of Earth, but its exact size and composition remain uncertain. This uncertainty stems from the difficulty of observing a region buried beneath thousands of miles of dense gas. However, data from the Cassini spacecraft has provided clues, suggesting that the core may be more diffuse and less defined than previously thought. Saturn generates more heat than it receives from the Sun, a phenomenon linked to its core. Scientists believe this heat comes from helium rain within the planet. As helium droplets form in Saturn's upper atmosphere, they sink toward the core, releasing gravitational energy as heat. This process is a key driver of the planet's internal energy and contributes to its dynamic weather patterns. The heat from the core also affects Saturn's atmosphere, influencing the formation of storms and the movement of wind currents. It provides a stark contrast to the planet's frigid outer layers, where temperatures can drop as low as -288 degrees Fahrenheit. This interplay of heat and cold creates the unique atmospheric dynamics observed on Saturn. Understanding Saturn's core is essential to unraveling the secrets of giant planets. By studying its structure and energy sources, scientists can learn more about the processes that shaped not only Saturn, but also other gas giants and exoplanets in distant star systems. Saturn's role in shaping the solar system. Saturn is not just a celestial marvel, it plays a significant role in the architecture of our solar system. As one of the most massive planets, its gravitational pull has a profound impact on the orbits of nearby celestial bodies, shaping the paths of asteroids, comets, and even its own moons. The planet's gravitational influence is believed to have helped stabilize the solar system during its early formation. By capturing and redirecting stray objects, Saturn likely prevented many collisions that could have disrupted the development of the inner planets, including Earth. This protective role has earned Saturn the nickname of a cosmic guardian. Saturn's interaction with its moons adds another layer of complexity. Tidal forces between the planet and its moons, such as Enceladus and Titan, drive geological and atmospheric activity. These interactions not only shape the moons themselves, but also contribute material to Saturn's rings, creating a dynamic system of mutual influence. The planet's position in the solar system also affects the Kuiper belt and the Oort cloud, regions filled with icy objects at the outer edges of the Sun's influence. Saturn's gravity, combined with that of Jupiter, helps steer comets toward the inner solar system, where they can be studied in greater detail. These icy visitors often provide valuable information about the early solar system and the building blocks of life. By studying Saturn's role within the solar system, scientists gain a deeper appreciation for how planets interact with one another and their surroundings. Saturn's gravitational dance is a reminder of the intricate and interconnected nature of our cosmic neighborhood, highlighting the planet's enduring significance in the grand scheme of the universe. Saturn is more than just a planet. It's a cosmic masterpiece filled with wonders that stretch the boundaries of our imagination. From its majestic rings to its mysterious moons and dynamic storms, Saturn continues to inspire awe and curiosity. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep exploring the universe with us.